Morning. Everybody can hear me? Or? Yeah? Oh, I didn't think this. Tricky this year. Okay. Well, okay. Normally I don't use these, so this is the first time. Morning. Everybody awake?
Yes.
Yeah? Everybody had enough drinks last night?
Yes.
Who didn't?
You did.
I didn't. Yeah, I fell asleep. Sorry. Well, you know. How many Trekkies around here? Raise your hands. Not enough. Damn, all my puns will not work. So, federating VoIP switching. Honestly, this is a subject that I've been more or less contemplating and talking about for the past 3 years. Basically, scalability. How do we scale voice over IP networks beyond the norms of what we know? How many of you have systems that range to 10 million users, 10 million subscribed users concurrently? Not GSM networks, SIP networks with 10 million subscribed endpoints. Any of you? How about 50 million? How about 100 million? How does Skype do what they do? How does WhatsApp enable you to call 350 million subscribers around the world, voice point to point? How is that possible? What kind of infrastructure do they use? Do they really have SIP servers that support everybody? Does that make any sense to you? If somebody says that it makes sense, then please raise your hand. Nobody raises their hands in fear. I may say something stupid. This is the presentation where you're allowed to say stupid things. You know why? Because none of you know how to do it. You reach a point of 1 million users and you're happy. But what do you do with 50 million? So this is what we were talking about. Now, first of all, because this is a Trekkie presentation, we've lost a great man this year. So a pun that was made earlier this convention was sip long and prosper. So I took it and I said, yes, we should sip long and prosper because this is what we do. For people who don't know who I am or what I do, this is more or less what I do. I'm a crazy person. I admit it. I should be committed because I do crazy stuff. This is what I do. I'm the person behind 3 different, 2 international endeavors, one which is local to Israel, which is PHP ARI, and Humbug, which is a fraud analysis system, and so on. You can look them up on the internet. I won't go deeper into that. So when we're talking about voice over IP, or at least open source voice over IP, the world looks a bit like this. It's, anybody know what the Starfleet, Star Trek Starfleet starships are? We got the Excelsior class, Enterprise class, Sovereign class, and this is more or less your open source world. We got Asterisk, Chameleon, OpenSIPs, FreeSwitch, Yate, MobiSense, and there are other projects being spun out on a daily basis, be it kits for developing all kinds of tools and so on. And the nice thing about this is there's all these ships, all these vessels. So each one has its own strengths. I can actually hear every time I start up Astro, I can actually hear Scotty inside. The engine is not working right. Yeah, that came out wrong, I know. Do we have a Scottish person in the crowd? Where's Peter? Peter is not here this year. Unfortunately, he could do better than I am. And, what?
That's what happens when you get engaged.
Yeah, that came out yesterday. Yeah. So each ship, each of these vessels is fully capable of taking care of itself. Take Asterisk, 5,000 users, 10,000 users on a single machine. Great. Take Chameleon, 50,000, 100,000, 500,000 registered users on a single box. Yay! What's next? More servers, more management, more tools? Doesn't work. We need to rethink this. So what does this have to do with VoIP? everything. Because voice over IP, the entire voice over IP world or industry is very much like Starfleet when you think about it as an analogy. Each of the engines is very powerful, very flexible, capable of doing a shitload of stuff. By the way, if you're offended by the fact that I may say something obscene from time to time, don't be. And of course, each vessel has its own charismatic captain. Normally, that will be us. And normally, they're all more or less capable of working together to an extent. Now, what do I mean by an extent? Effectively, if you take Asterisk and FreeSwitch and Yate, what do you see? You see this. Different UI, similar functionality. Two different generations of the same captain. So essentially, it's the same functionality, but a different UI. So in a state that we are today, I don't see much difference between Asterisk and FreeSwitch. Capabilities are more or less identical. Version 12, version 13 of Asterisk got stuff that previously was more or less the realm of FreeSwitch and made it better and said, you know, we've learned, we know how to do it right, which is awesome. So what are the issues that we're tackling with scaling beyond that point where we are all at? So the problem of VoIP scalability, at least as it is today, is that it's vertical. More channels, more CPS. Anybody has a Veraz soft switch? Dialogic now? Any of you? Broadsoft, Sonus. Come on, what are you guys using? Nothing? No? So every time you go to there, more channels, more calls per second. Okay, please fork up $500,000. That's how it works. More servers, more session border controllers, more databases, more. It never ends. And the more you put in, that's putting money aside, okay? Forget about money. Let's say we have no budget limitations. The more we put in, the more we manage. So it is no longer a question of just saying, okay, so I've got a big network there. I need more management. I need more personnel. Have you seen the IT department of a medium-sized carrier, let's say 10 million subscribers? How many people are in there? 10, 15, 20, 30? How many people are working for, I believe there's somebody in the crowd here from Nexmo, right? How many people work for Nexmo? 150. Out of those, how many are in operations, support, and IT? 40 people manage the Nexmo infrastructure. And as the Nexmo infrastructure will grow, that will grow because the normal ratio is one person for around 20 servers. You cannot do more than that. The human capability of an IT person cannot manage more than that. It just doesn't make sense. So, increased points of failure, the more servers we have. The more infrastructure we have more points of failure. In other words, more personnel. Again, more money, and of course, much more money. Much more money. We've all known the much more money case, right? We've seen companies going about raising over a period of 10 years $250 million or $500 million without reaching their goals. We've seen that happen. Why does it happen? Because the paradigm is just wrong. We've been doing it wrong. And there's a very old saying in the telecom industry, how do you make a small fortune? You start with a big fortune. And that is relatively true. Because at some point, the expense that we run in order to run a telco business, to run a carrier, to run a Nexmo equivalent, a Twilio equivalent, or whatever you've got in there, just requires a lot of money because it becomes a big operation. So how do we take that operation and say, you know something? We're going to do the same, but with a team of 6 people or 10 people? How do we do that? Here's an interesting question. If I would have had a network of, let's say, 1.5 million subscribers, what will be my, let's say, my entire company technical overhead? This is an open question. How many people do you have? Anybody here has a company that serves 1.5 million subscribers? Raise your hand. Okay, how many people have you got in your tech teams? 6 people in the tech team. Sales team? Ops? So tech and ops are 10, 16. Another hand were raised. Same 1.5 million subscribers, 16 people handling that. Now, what if I tell... Actually, a bit more than 1.5, fine. Let's make it 2, around 2, okay, fine. What if I tell you that you can do the same with 1 person in your tech team?
Depends. If it's just management, yes. If it's developing new features.
I'm not talking about development. I'm talking ops and support. So let's think about federating it. What does federating mean? So first of all, cloud-based switching logic core. Normally, we think of switching logic as part of our switch. Wrong. Move it aside. Take it somewhere else. I have seen all too many installations of Asterisk, Chameleon, FreeSwitch, where people had written so much logic into that switch that it completely became unscalable, unmanageable. Don't do that. First thing. Discrete functional units. What does that mean? It means that if you take a server or a function within your network, it does the same thing over and over and over again. You can replicate it over and over and over again without the need to reconfigure it. You don't need to go about and say, okay, now I'm going to change this, I'm going to change that. No, it has to do the same function over and over again. Think about it as your toolbox. You know, a plumber comes into your house, he has that toolbox, tool chest with him, puts it in. He has a wrench, each tool does the same thing over and over again. It's UA-centric, not switch-centric. Most companies, most carriers, most infrastructures are switch-centric. That means we are looking at the system from a switch point of view giving service. We're not looking from the client and user experience, from the UA side of the system, saying, wait a minute, what does the UA need? What does the UA truly, what can it do? Because UAs now are very smart. We have smartphones. We have Android-based IP phones. These machines are really smart. Let's move part of the equation back into the user agent. We can do that. Distribution via provisioning, not via sharding. Now, we shard our systems to death. More media servers, more signaling servers, more. And how do we shard? We use numbers. We use routing plans. So we shard statically. Stop doing that. If you continue on doing that, the only thing that you'll end up with is a mesh network which is completely unmanageable. Imagine the following. You need to manage a full mesh network of 64 sites. And you have to reroute full mesh from one site to the other all the time. You'll have a heart attack before you manage to do that. And you'll lose all your hair. Most of us are already at that point, no? What? Okay, no single point of failure. Now, this is a very big statement. How can we create a system that has no points of failure, or at least a single one? We're going to see that in a few seconds. And, of course, it has to be Starship agnostic. Pick your tools. Chameleon, OpenSIPs, Asterisk, FreeSwitch, Yate, MobiSense. Put them all in. I don't care. Use whatever you want. As long as you keep on to the methodology, it will work. And the nice thing is that you can combine the two. You say, okay, so this part I'm going to use FreeSwitch, and this part I'm going to use AstroSwitch because this one gives me a better control over here, and that one gives me better control over there. But at the end, if the logic is outside, you can do that. So what does it actually look like? Again, this is from 50,000 feet point of view at this point. So what we have is a switching logic core. Normally, it will be inside a cloud container. Take your pick. My personal favorite, Google App Engine. Why do I like Google App Engine? Because it will give me the same consistent performance wherever I go. I'll be in the US, I'll be in Europe, I'll be in Australia. No matter where, it will always be the same. I will get the same data store, I will get the same CDN, I will get the same results over and over and over again. And yes, it does mean that I will be putting much of my knowledge inside Google, but they already have it anyway. So why not? Privacy is gone, right? We already agreed on that yesterday. Each one of my nodes, I have two specific nodes, or node types. I have what I call an edge node, which normally connects out to the world, let's say into the PSTN world. And I've got a subscriber node that serves my various user agents. Routing between these is performed dynamically. None of these actually know of each other, ever. They're not supposed to know of each other. They will know of each other the minute they need to. From that point onwards, they will be aware, because the system is capable of learning. That's why we have the remote switching cache. The cache is meant to say, okay, I've reached a decision as to where something needs to be routed to. That decision is now cached. From that point on, I can use that cache over and over again for a certain period of time, let's say 5 minutes, which is normally what you need. So, step one in getting there, provisioning. User agents have no knowledge as to their designated serving switch. What does that mean? Normally, when we have, let's say, a normal network, then let's say we're using TR69 or we're using DHCP option 66 to configure our IP phones or whatever. So we'll have some form of static configuration file drop into our phone, and that configures it. Stop doing that. It's ridiculous. It really is. If you're going to do something, do it with the proper provisioning script that will go somewhere and say, okay, please go to that server. At that point of provisioning, you should provision that user automatically. At that point as well, your logic core, your switching logic will actually change all the routing paths inside the system saying that user is currently there. What have we created? No single point of failure for a user. Stop working? No problem. Just reboot the phone. In a right system, in a system that's built correctly, every problem should be handled by a single solution, at least from the user's point of view. Reboot. That's it. That's it. That should be the only solution a user should know. If you tell him, go to settings, go here, go there, no. You're doing it wrong. The only solution a user should know is reboot your phone. Point blank. Server designation is determined ad hoc. You never know where the user is. It's fully dynamic. The system knows it according to its capabilities and according to the resources it has. That server is becoming loaded, please move so-and-so users to that server. The system is always capable of balancing itself. This is a lot of logic work to do at what I call the switching core. Upon server failure, we need to be able to push a message into the phones, and we're fully capable of doing that, saying, please resubmit your configuration. Basically, go back to the configuration server, to the provisioning environment, and say, I want a new configuration file. We're fully capable of doing that today. IP phones have that. Mobile phones have that. You should use it. Redistribution of clients, of user agents across the network uses the same provisioning tools. You don't need to redo it. Use the same tool over and over again. And data sharding is performed naturally. Because if you do it like that, you don't need to worry about where anything sits. It will happen on its own. Unlike databases, MySQL shards, Mongo shards. What is my data structure? No. Your voice over IP people, your networking people. Think from a networking perspective, not from a database. We've all been stuck inside the database paradigm till it killed us. We're all thinking like DBAs, not like networking people. Stop doing that. Routing logic. No static routing. And I do mean no static routing. There is no such thing. The only place where static routing should be is only one place, at the edges. Routing decisions are determined ad hoc, according to your logic, according to where you're located. If your network won't do that, you won't be able to scale. It sounds right now at this point, people are looking and saying, that makes sense in some form, but how are we going to do that? I'm going to show you in a bit. Transcoding and media, the pitfall of voice over IP networks, right? Anybody here likes transcoding? Nobody likes. How many people use session border controllers to control their media? Hands up. 2 brave people, 3 brave people are actually admitting to it. In an ideal implementation, there is no transcoding. Transcoding is limited to the PSTN edges only. Media services such as voicemail, conferencing, IVR, etc., are performed where the call is, not where the call goes to. That means that there is no designation to where your IVR sits. There is no voicemail server. There is no IVR server. There is just an IVR. There is just an application that will go out into the switching core and say, bring me that IVR because I need it. And will bring back a version of that IVR applicable to that location. And it's dynamically created. One codec to rule them all. Personal favorite is Opus. I do know that some carriers still limit to G711. Yeah.
Why is it Opus?
Well, my personal favorite Opus is because A, it has variable beat rates. It enables me to adjust my transmission rate as I go along. So if I have a better network, I'll just provide better quality. And issues like forward error correction are handled within the codec, within the RTP engine. And echo concealment, noise suppression are done internally as part of the codec. So from a codec point of view, it is a perfect codec to work inside a mobile environment, in my respect. Yeah.
I would like to add it's the first real open codec that's built for internet.
That is true, yes.
G711 and the rest is built by SDN, and we have Opus do them first. But this is built by people who know the internet and how it works. Namely, Alan Rick was here yesterday, but he's not here today, and a bunch of other guys.
Yeah. Okay. Yes. Yeah. Step 4, fault tolerance and DRP. Your system is only as good as your infrastructure. Last year at Astricon 2014, anybody know who Russell Bryant is? Okay, so Russell used to be the project lead for Asterisk. He's now with the OpenStack. And when he said that over his keynote, I was like, oh my God, that is basically the point here. We're all building infrastructures, huge infrastructures, but we're building voice infrastructures. We're using traditional tools. We're using the norms that we're so accustomed to. Stop doing that. I would rather build a whole network of, of OpenStack servers and do everything virtualized inside an SDN than to install one session border from Acme. Honestly. Really. A federated system doesn't require DRP or high availability. It does it naturally. It's part of its DNA. It's part of its design. If it's designed to work like that, you don't need DRP. DRP is built into the algorithm. Fault tolerance is just as good as your cloud is. So if your OpenStack is fully capable of migrating virtual host instances from one side of the network to the other side, as it happens with Amazon and, pardon me, and most of the cloud providers these days, it will work fine. A federated system is platform as a service and infrastructure as a service ready, always, because that's how it works. That's how it's designed. So how did we build ours? First of all, as I said, routing logic, provisioning, billing, CRM. Normally we do that on Google App Engine, simply because it scales well. Yeah. Hosts, Camilio, Asterisk, Stun, Turn, either Google Compute or DigitalOcean. Normally, if we don't want media to traverse, we'll use DigitalOcean and not Google due to NAT considerations. Data warehousing, normally that will be Amazon Redshift. Anybody familiar with Redshift? Okay. Analytics and ops, of course, the usual candidates, Hadoop, Kibana, and Icinga, which are one of the three of our favorite tools. If anybody wants to know more what we do with these, you're welcome to catch me afterwards. Things you need to build. First of all, client provisioning integrated into UA itself. Can be either a JSON API or normal provisioning interfaces, but make it dynamic. Make sure it's not static files. Make sure it has some kind of logic behind it. Server provisioning, that means my media server, my signaling service come up and down as I need them inside these clouds. Today I need $1,000 worth of hosting, tomorrow I'll need 200. Why? Because I lost 80% of my users. Or tomorrow I'm doing an ad campaign and I gain 20% more users, I need to launch up new service. It needs to be dynamic. I don't need somebody to go in and press a fucking button. Routing and authorization. Again, everything is done ad hoc. These are your tasks. These are the things you'll have to do in order to get your system fully federated. Now, Project Matrix that is presenting outside is a very good example of how you federate inside WebRTC. But federating SIP is slightly different, but the norms, the paradigms are very similar if you'd look at them deeply. Questions? Behind you.
First of all, I got a couple of problems with the presentation. Okay. First of all, yesterday we did not agree that privacy is gone. We agreed that privacy is endangered and we should protect it.
Well, true. I'll grant you that.
And by putting a lot of personal information and personal data into the cloud, you lose control when you are legally obliged to delete it. And if you put a lot of personal data into, for example, Google Adventure, you're violating a lot of data privacy laws, which in the end makes you a criminal.
I'll tell you this. So my answer to this is the following. The minute your service will deal with smartphones, the data is already there. That's one. They already have it. Number two, you can always build your own. You don't have to use Google App Engine. We used Google App Engine simply because it was the fastest tool to use, and it was, let's say, lowered our management overhead. Number two is that we've checked from a legal point of view, and in several countries, more than one, Google App Engine is considered a secured environment, even for banking. Same applies to Amazon Web Services. So the end result is that privacy is being compromised these days, yes. It is becoming harder and harder to keep ourselves private from the network. Yes, can't do anything about it. But you let go your privacy because you want something. You let go of your privacy because you're willing to let go of it. You let it go the minute you bought that smartphone. The minute you bought that iPhone, you've done it. In 1984, anybody remembers that commercial for Apple Mac? Why 1984 will not be like 1984. Well, here's news. We're back at 1984, and now Apple is IBM. Apple is Big Brother. Same place as Google. Whether you like it or not, they have your data. Google has it, Facebook has it, Uber has it. Well, not Uber, well, part of it. So you've already let go of it. So the claim of saying because you put it in Google App Engine, you're violating laws, not at all. That has already been checked. Yes?
Curious,
Curious, what did you find the difference between Google App versus AWS?
Well, Google App Engine is not servers. It's a services platform. So basically, you write your code once, they will distribute it across the world as needed. So I don't need to worry about data centers. I don't need to worry about distribution of code. I don't need to worry about management. So the data store is one data store. So it's Google Data Store. And the App Engine gives you data all over the place in a very consistent manner. So regardless, for example, if you take Amazon Web Services, okay, so you say they have US North, US West, US East. So you're always in that equation, where do I have more users? From Google's point of view, that's not really interesting. You need it, we'll spun up an instance where it's required, we'll shut it down when you don't need it. That's the idea.
Other questions? No. I have a couple of announcements to make before the break. So